Tutorial number 7, question number 1. The mechanism shows rotates about the vertical axis with an initial angular velocity of 2 radians per second. Initially, the two masses are in a horizontal plane, as shown by the solid lines. A hinging system internal to the mechanism then lowers the two masses to 30 degrees from the horizontal plane. If the mechanism is freely spinning, what is the angular velocity of the mechanism after the masses are lowered? So, because there's no friction, we could say the angular momentum around the axis is conservative. So, HO1 is equal to sum HO2. And here is our status 1, here's our status 2. So we have 2md v1 is equal to 2md cosine beta v2. v2 is equal to 1 over cosine beta v1. Also, v1 is equal to omega 1d, which is equal to theta 1 dot d. v2 is equal to d cosine beta theta 2 dot. We put these two into our equation. We have d cosine beta theta 2 dot is equal to 1 cosine beta theta 1 dot d. Then theta 2 dot is equal to theta 1 dot cosine beta square, which is equal to 2 over cosine 30 degrees square, which is equal to 2.67 radians per second. Question B. A motor on the shaft is then turned on for 3 seconds and returns the rotational speed of the shaft to 2 radians per second. The masses stay in the dashed configurations. What is the average moment supplied by the motor? Then question B, we have the angular momentum as status 2 minus the work done by the angular momentum created by the motor, which is T2 to T3, equal to the angular momentum at status 3. So we have 2md square cosine beta square theta 2 dot minus T2 to T3 moment O t dt is equal to 2md square cosine beta square theta 3 dot. We have the definition of the moment, average moment, which is moment O average is equal to 1 over T3 minus T2 integral from T2 to T3 MO T dt, which is equal to 1 over del T integral T2 to T3 MO T times dt. So delta T moment average is equal to integral T2 to T3 MO T dt. We put this back to our equation. We have MO average is equal to 2md square cosine beta square delta t times theta 2 dot minus theta 3 dot, which is equal to 2 times 0.6 times 0.2 square cosine 30 degrees square over 3 times 2.67 minus 2, which is equal to 0.00804 Newton times meter. Question 3. How much work is done by the motor? So T2, which is the kinetic energy at status 2 plus the work done by the motor, is equal to T3. T2 is equal to 2 times 1 over 2 mv2 square. T3 is equal to 2 times 1 over 2 mv3 square. U1223 is equal to mv2 square minus v3 square minus v2 square. M d cosine beta c2 dot square minus d cosine beta c2 dot square, which is equal to nd square cosine beta square theta 3 dot square minus theta 2 dot square is equal to 0.6 times 0.2 square times cosine 30 degrees square times 2 square minus 2.67 square, which is equal to negative 0.0563 joule. Question number 2. Motion of the rectangular plate P is controlled by the two links which cross without touching. For the instance represented where the links are perpendicular to each other, the plate has a counterclockwise angular velocity which is equal to 2 radians per second. We need to determine the corresponding angular velocity of the two links. First idea come to our mind is to figure out the point velocity of A and B in order to get the angular velocity of these two links. So if we define this point as C, we will know that BC will be 0.5 minus 0.2, which is 0.3. Then AC will be 0.4, and AB will be 0.5. And if we define our Cartesian coordination, here's our I, here's our J, and K will be counterclockwise to positive. So we already got the angular velocity of the plate, which is omega AB is equal to omega plate, which is equal to 2k radian per second. And also VA is equal to VB plus omega AB cross A relative to B. So we already have VA is equal to omega AO cross ROA. VB is equal to omega BD cross RDB. So if we put these two equations into our second equation, we will get omega AB AO cross ROA is equal to omega BD cross RDB plus omega AB cross RBA. Omega AO is equal to magnitude of it and times the direction, which is k, cross 0.6 j is equal to omega BD k times 0.5 I plus 2k times negative 0.3 I plus 0.4 j. So it's equal to 0.6 omega AO. I is equal to 0.5 omega BD J, minus 0.6j minus 0.8I. So in I direction is negative 0.6 omega AO is equal to negative 0.8. So omega AO is equal to 1.33 K radian per second. In J direction, 0 is equal to 0.5 omega BD minus 0.6. So omega BD is equal to 1.2 K radian per second. Question number 3. At the instance shown in the figure, point B of the T-shaped bar has a velocity of 1 meter per second and an acceleration of 2 meter per second square. We need to determine the velocity of point D in xy coordination as well as the angular velocity of T-shaped bar. So we already have the velocity of point B, which is 1 I meter per second, and acceleration of B is equal to 2I per meter per second square. So we need to find is Vd and omega. So Vd is equal to Vb plus omega cross R BD. According to our diagram, we will say this is 1, this is 1, here's 45 degrees, so BD is square root 2. So R BD is equal to square root 2 J. So Vd is equal to Vbi plus omega K cross RD relative to B J. We can rewrite our coordination system. Here is I, here is J, and here is K. You can cross your four fingers from K direction to J direction. You will find your thumb will point at negative I direction. So this part we can write it to omega R D B I negative. So VBI. So VB is equal to VD is equal to VB minus omega R D relative to B I. So to get the velocity of point D, we need to get the angular velocity first. So we have we can calculate the velocity of A to solve this problem. So VA is equal to VB plus omega cross RAB or BA. So according to the diagram, we'll say RBA is equal to negative RBA cosine 45 degrees I plus RBA sine 45 degrees J, which is equal to negative square root 2 I plus square root 2 J. When we put it back, we will get negative VAJ is equal to 1 I plus omega K cross negative square root 2 I plus square root 2 J. So negative VA J is equal to I plus negative square root 2 omega J minus square root 2 omega I. So we will get negative VA is equal to negative square root 2 omega. 0 is equal to 1 minus square root 2 omega. So omega is equal to 1 over square root 2, which is equal to square root 2 over 2. So VA is equal to square root 2 times omega, which is equal to 1. So VD is equal to VB minus omega R BD in I direction. So VB is 1 minus square root 2 over 2 times square root 2, which is equal to 1 minus 1 in I direction, which is equal to 0.